From Kavi, actually, they have also the project from the West Java government to collect sample from Kuningan Botanical Garden. Kuningan might be 100 kilometers long from here. Maybe can they also inside?
Yeah. So berapa sample? How many will
How
you?
many sample? At least 100.
I don't know.
Yeah.
Maybe I try to collect 2 samples.
Yeah. Yeah.
How many do you?
So I mean, we want to collect, Lima River, yeah,
5,000 samples.
which is a lot, but it is possible. And I would say when you collect Lima River sample, mungkin very boring, yeah. But then when you have a collection, you can test it very quickly. And it's a bit like, the more samples you have, the more active samples you can, more possibility. Yeah.
Jadi kemungkinan nyawa aktif itu ada 1% dari jumlah sampel yang kita koleksi. Jadi kalau kita mengoleksi 5.000, kemudian kita akan mendapatkan 50 tanaman yang aktif. Dari 50 tanaman mungkin reduksi lagi menjadi 5 yang berbeda.
Yeah. Like
1%.
Like the when you buy a ticket to win money.
Yes.
How do you say the lottery?
Yes.
Yeah. If you want to win the lottery, don't buy one ticket. Yeah. So like as an example.
Like gamble.
Yeah, like gambling. But with gambling is bad. Yeah.
Yeah.
But
Lottery.
yeah. So gambling, the casino always wins. Yeah. But if you play gambling and you play 5,000 times, you probably win something. And a good example of this is in the cancer screening. In the 1980s, they tested 33,000. Yeah. So in the 1980s, they tested 33 plant untuk cell cancer, and from 30 pohon 30 we get impact drugs. Yeah. So mungkin 33,000 for drugs, I think.
Jadi NCI itu National Cancer Institute di Amerika, dia men-screening 200.000 sampel.
No, 30,000. 33,000.
Ya, dari 30.000 tanaman.
Yeah.
Hanya dapat 4 obat. Tapi itulah itu dia.
Yeah.
Usaha.
Yeah, but how many plants are there in Indonesia? Does anybody know? Kamu tahu berapa?
33.000.
No, 40.
40.000.
Yeah. Yeah, Indonesia.
Dr. Enda already here? And any questions for you?
Belum.
Ya, belum.
Hello.
Dr. Enda from Faculty of Agriculture. Okay, any more questions? From audience, from the Zoom?
Yeah. Satu pertanyaan lagi.
Pertanyaan. Pertanyaan is mean agriculture. Pertanyaan is mean question.
Okay.
Ada pertanyaan.
Pertanyaan.
Prof. Sri Rahayu from Bogor Botanical Garden. Prof. Sri. Dari siapa nih? Prof. Sri.
Iya, Prof.
Any more question from you? Professor Sri actually from Bogor Botanical Garden.
Okay.
Okay, Prof. Sri.
Okay. Yes. Sorry, I cannot open. Sorry. Okay. Hello. Nice to meet you. Maybe I'm interesting also in your topic of seminar today, and I would like to ask how many species maybe, especially from tropical country, have you already maybe test test and have effective effect as fungicide, maybe not only from Indonesia.
Thank you. Very pleased to meet you. Hopefully we can work together. Yes, so that's a very good question. So I think from the literature, not many species already tested.
Okay.
And because what I think happens is like one research group just tests very small numbers, maybe like 10 plants or 5 plants or something like that. So if we put all the publications on this topic, it's not many sample that is tested. So I think if we test 5,000, then we are testing more than everybody else in the world already. That's my assumption, I think.
How to decide 5,000? I think that's too very 5,000 species or maybe accession.
Yes.
Yeah, I think if we can do species, it's better.
Yeah.
I don't know if it's possible, but we want to maximize phylogenetic diversity. So
Okay.
probably we want to collect, make sure that the 5,000 are across different genera, different families with maximum phylogenetic diversity. I think from our experience, it is possible to collect because we only need a very small sample.
Yeah, small sample.
We're talking a very small sample.
Oh, okay. Very small
So-
is possible, but if you need, let's say 1 kilogram per accession, will be
bukan
difficult.
Putri, dalam screening ini kita hanya perlu 2,5 kali 2,5 sentimeter. Jadi kita
Oh,
gunting
okay,
saja.
okay.
Jadi daunnya
Okay.
itu hanya diambil 1 lembar, kurang mungkin.
Okay.
Jadi hanya
Yeah.
5 centimeter.
Ya, mungkin 5 centimeter juga sedikit.
5
mungkin
centimeter,
2
okay.
centimeter.
Yeah, that's
sedikit.
possible.
Yeah, and how do you say, from the leaf only.
Dari daun.
Daun saja.
Jadi kita hanya ngambil dari daun saja, Bu.
Okay.
Dari daun kita ngambil 5 kali 5 cm, kemudian kita gunting, masukkan ke dalam vial, masukkan ke dalam metanol, filtrasi.
Yep.
Nanti di lab kita saring itu, Bu. Pindahkan ke 96 kayak tadi. Jadi screening total gitu.
Okay,
Jadi yang
yeah.
hampir tidak dipotong tanamannya, hanya sedikit
Okay.
aja.
Yes. I will be happy to be included in this project.
Sure. Terima kasih.
Yeah.
Terima kasih.
Yeah.
Ibu nanti kita ke Bogor lagi ya, Bu ya.
Ya, Pak.
Nanti
Siap.
kita ke Bogor.
Iya, siap.
Doakan proyeknya berhasil.
Amin. Okay. And hope the project will be run well. So yeah.
Thank you.
Thank you.
Yeah.
Any more question from the Zoom? Bu Enda, ada pertanyaan?
Apa ya? Maaf karena tidak mengikuti.
Gitu ya. Itu aja
Nanti aja
memuji fungicida.
Tadi sudah dibahas belum ya?
Belum.
Oh, lain. Oke.
Oke.
Pertanyaan apa ya?
Bebas.
Okay, just maybe I don't know. It's already you already described or not? About the testing of the pathogen.
Yeah.
Yes. So it's just we still will use the pathogen from coffee or chili or.
So that's a good question.
Yeah.
Probably we need to decide which pathogen. Probably maybe Rhizoctonia solani, but actually maybe better the different pathogen, of potato crops and chili plants. So maybe not Rhizoctonia solani. And maybe we do the initial testing with just something that's very easy to grow in a 96 well plate, just like Aspergillus. And then when we get an active, then we test it. Well, you're the expert for plant model of infection. So then we test the active from the screening in a plant model using chili plants or something like that. Yeah, tomatoes. Yeah.
Yeah, I think chili will be easy.
Yeah.
Okay, thank you.
Silly. Okay, any more question? From the male student, Aja? Bahasa is okay.
Yeah, bahasa bisa.
Okay, please. Bahasa kuat.
Assalamualaikum. Nama saya Fajar. Pengalaman saya di tanaman cabai itu memang virus yang ada pada cabai itu memang selalu bermutasi. Karena kultur di Indonesia sendiri pupuknya memakai yang kotoran ayam yang telah dimodifikasi sama makanan suntikan-suntikan dari ayam sendiri yang kotoran, jadi bermutasi pada tanaman cabai. Nah, petani-petani yang ada di wilayah selatan sendiri itu memerlukan suatu formulasi yang melawan mutasi tersebut. Jadi belum ada sampai sekarang yang bisa
Jadi bukan fungisida ya, tapi virus.
Seperti virus gitu, Pak. Yang saya tahu berdasarkan dari teman-teman saya sendiri, mungkin itu masalahnya, jadi belum ada. Mungkin bagaimana menurut
Cabai actually not pathogenic fungi, but also virus.
Virus, yeah.
What do you think?
Yeah, so I think virus is much more difficult. It's a good question. With fungi, kami senang sedikit ya, karena jumur ya. Fungi is jamur. Jamur. Kami bisa membuat jamur di laboratory. Ya, tidak ada banyak masalah. Tetapi dengan virus, saya takut sedikit ya. Kalau kami mau tahu mekanisme dengan virus, tidak bisa ya. Mungkin mungkin lebih baik dengan bacteria or jamur, ya lebih baik. So jadi saya tidak tahu dengan virus. Enda, kamu kerja dengan virus?
Yes. I think if we want to do with virus, what we can do is for the systemic resistance. Yeah, so we use extract. We use plant extract for immunization.
Yes.
Yeah.
Yes.
Yeah. Ya, memang di cabai memang virus, and then the Colitrichum, the fungus is also the very pathogen.
So masalah dengan virus tidak bisa membuat
Tidak bisa dibiarkan.
like screening dengan plant extract like 5,000 ya tidak bisa. So tetapi dengan jamur bisa screening ya. Sorry,
Maybe we need to back biosafety level 3, right? Virus. We have to screen.
maybe
We have to grow up.
biosafety.
But to grow up the virus, and after that screening for the antivirus.
Yeah, I mean, any in natural products, any any project that uses a very complicated assay, yeah, it creates a lot of problems, right? If your assay is like very expensive or very complicated, you're not going to be able to do screening. And then if your assay is very complicated or expensive, when you want to isolate the compound, oh, it's very mahal sekali.
Very expensive.
Yeah, yeah. So, so saya suka jamur, ya.
Jamur.
Fungi.
Ya, fungi.
Yeah, yeah.
Any more question? Any more question? Pak Kini, Dr. Kini, please.
Thank you very much. So you choose 5,000 plants. Is it randomly choose 5,000 plants, or you have, for example, like ethnopharmacology knowledge before you choose the plants?
Yeah. Oh, yeah, good question. So, in the 5,000, it should not be random. It should include first samples already published from Indonesia as active. Yeah. And then next, samples that are already used either as food or medicine. So it's already eaten by human beings. Yeah, and then next, maximum phylogenetic diversity. So it should not be random. Yeah. Thank you.
Okay, any more question? Ibu Mega? I will run it.
I have a question regarding the mode of action for the fungicide.
Yeah.
You mentioned earlier that I think most of the mechanism as fungicide is to disrupt the phospholipid layer, but actually you are trying to find another mechanism which is as iron chelator.
Yeah.
So are you doing that to find new fungicide that is not resistant, or and after that you are also trying to find like new assay for that?
Yeah.
So you actually develop the assay. So how the bioassay? Yeah. So how is the actually the background that needs to be known so we can develop it? Like you can test with some kind of fluorescent compound.
Yeah.
So yeah, I think that's the question.
That's a good question. Yeah. So we want to know the mechanism because you can't. So if you want to have a new fungicide in Indonesia, the government will want to know, like, what is the mechanism. Also, if you want to publish, the mechanism is what makes a good publication. So chemicals by themselves don't publish themselves very happily. If you just have chemicals, it's quite hard to publish. If you have chemicals and the mechanism, you get higher impact. The question of mechanism is interesting because we don't know anything much about mechanism of action of fungicidal plants. You know, it's not very studied. And also in natural products, the mechanism is the thing that is most likely to be wrong. Yeah. So if you look in publications, that's the bit that actually where the errors, where the mistakes are. And even we can see if we look in a different field, okay, so not fungicides, if we look at the cancer field, we even see that big companies get the mechanism wrong. It's a very difficult problem, basically. So we can find examples of publications where the mechanism is probably wrong, actually. So it's a difficult topic, but antifungal is an area where there are good methods, so it is possible to kind of answer this question. Yeah, a novel mechanism is good because exactly like you say, resistance is less of a problem with a novel mechanism. And the problems that exist already is when people are using like triazole fungicides in agriculture, and it has the same mechanism in for triazoles for human medicine. We want to avoid using the same mechanisms that are used in human medicine. But sorry, I forgot your question. Yeah.
The second question, is
Yeah.
regarding how like the technique to develop new assay. Like you mentioned that you actually developed the assay by.
Yeah. So I didn't develop, well, we modified the assay. So yeah, so I worked a little bit with a big pharmaceutical company called Novartis, and they're in Switzerland. And I studied their assays, and then I took their assays, and now with my PhD student, we're developing new assays, basically. So yeah, that's why we use big collections of mutants to study, mechanism. Yeah. But I think in natural products, membrane disruption is quite common, or antibacterial, antifungal is probably more common. And then a big mistake in the literature on natural products is people assume that their compound interacts with a specific protein, and most natural products do not interact with a single protein. Like, that's very unusual. So there's for natural product scientists, there's a tendency to believe that their compound is like a drug, as if it's very, very, very specific. But normally, most people's compound that they isolated from a plant is not one mechanism, maybe 10, 20 different mechanisms. Yeah.
Thank you.
Enough, Professor Ari?
Enough.
Any more question? Dr. Omega? And Dr. Omega actually from the agriculture company. Okay. Any more question? No? We're not already. Okay, maybe Dr. Omega discuss you.
Yeah.
Okay, I think finish our guest lecture is give the big applause from Dr. Tom. Okay, Dr. Closing. Yes, thank you.
Yeah, thank you, Prof. Unang, to be a moderator for today's seminar. So thank you to Dr. Tom Prescott for a very interesting lecture and of course very interesting discussion. So I think this is the end of the seminar today. So we can close it by Alhamdulillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Okay, the last one, please give one picture.
Okay,
Come here.
Oh,
let's have picture together with Dr. Tom Prescott.
Over here ya. Oh, dari Zoom mau ikutan ya? Hah? Susah ya?
Susah.
Oh ya.
close aja.
Sini aja.
Yang share screen-nya aja di.
Semua ikut kelihatan semua. Banyak.
Ada tadi mah ada 90, 90 and now.
Kelihatan nggak? Kita kelihatan nggak semua ini? Gimana ya?
Ya, buka kamera.
Kita sekarang. Ya.
Atau dokter dulu.
Boleh, sama Prof. Unang.
Ya. Dua kali aja, Bro. Pertama yang
Pakai tipis sedikit.
Pertama di depan, nanti di sini
Nah.
buat yang di
Rotasi.
Kang Fajar.
Nah,
tangannya zoom dulu ya, satu sama.
Silakan tutup di sini ya.
rotasi apa deh? Oke.
Lanjut.
Dan aja ya. Oh, tadi aja. Sama kan?
Berarti.
Nanti kan foto lagi di sini. Nanti foto.
Kamera bagus kameranya? Bagus. Oh iya.
Kalau nggak bagus, awas
Yang di situ bisa open kamera barangkali.
Ada Bulela tuh.
Ada Putri.
1, 2, 3. 1, 2, 3. Tinggal 3 ya, Pak.
Satu lagi.
Satu lagi. Si. Chemistry.
Chemistry.
Si.
chemistry.
1, 2.
Oke.
Sekarang
Ya.
ada di kami ya.
Ya, oke. We move over there.
Yeah.
Ya, sebentar. Siapa di depan fotonya? Kasihan aku bagian gantian atau Mani.
What do you say? Cheese?
Cheese.
Keju.
Ah, same asli. Cheese same. Cheese.
1, 2, 3. 1, 2, 3. Oke, lagi.
Satu lagi.
1, 2, 3. Oke.
Oke, terima kasih.
Tapi nggak kebagian.
Bisa nggak tangan kiri? Pakai tongkat mau atau boleh?
How do we say in Indonesian? Thank you very much.
Terima kasih banyak.
For listening.
Sipan di situ.
For coming.
Terima kasih banyak atas kedatangannya.
Yeah.
Kedatangan.
Thank you very much for your time.
Yeah. Yeah.